Independence-class ship brief. This is the second of the two littoral combat ships that the United States has built over the past 13 to 15 years. LCS are really characterized by their ability to move at high speeds. They both employ trainable water jets and are able to get from zero to very fast in a short period of time. They're made of composite lightweight materials and have unique designs. The Independence class is probably the more radical of the two hull designs because of its trimaran design shape. Two of the ships have already been decommissioned, which when compared to the Freedom class is a success because Freedom class has had some 5 or 6 decommissioned already. And eventually all of these will be pushed out of the Navy or sold to other countries. Like the Freedom class is being proposed to be sold to Greece, for example. But this is the Independence class, and she shares some of the same weapon systems and sensors as the Freedom class. In the Independence class, we also are shooting the AMG 114L7 Hellfire missiles, and they have the Naval Strike Missile anti-ship cruise missile on the bow. Keep in mind that that anti-ship cruise missile is only installed on a limited number of the 17 hulls. They don't all have that system. But they do all have the Bofors Mark 110 57mm naval gun, a CRAM point defense system with rolling airframe missiles, and 2 Mark 46 30mm gun systems that we'll talk about today, including all the sensors and combat systems that connect these weapons together. Let's start with weapons and countermeasures. On the bow, we have the Mark 110 57mm gun. This gun has a limited depression capability. In other words, it doesn't shoot down very much, if at all. Right behind that is the AGM 114 vertical launch missile system that shoots the anti-surface missiles. These are basically the same longbow missiles that the Apache helicopter shoots, just a naval variant of it. And I'm told confidently that it has a slightly longer range than the Apache version, or the helicopter version. Behind that is the RGM 184 Alpha, which is also called the Naval Strike Missile. Very capable, modern subsonic, but stealthy anti-ship missile. And behind that is the superstructure with the bridge. And on top of this bridge, we have 2 Mark 46 30mm gun weapon systems, one facing port, one facing starboard. And amidships in the center at the very top is the CRAM point defense missile system. The Mark 137 decoy launcher is on either side, and we'll talk about those. It's just a combo launcher. We're talking chaff, flare, torpedo decoy, all combined into one now. It's a very good system. Let's move on to sensors. All these weapons are great, but if they don't have targets, they're not functional. So the way we get targets is at the very top, we have the electronic support measure system called ES3601. None of this information about the system is public right now. Just know that it listens for radars, and it processes and tells the crew what radars are out there and what modes they're in, what power levels they are. That is all done millions of times per second by this ES3601 ESM. Very advanced. Below that, on top of the bridge, again, another high point of the ship, is the Sea Draft anti-missile ballistic radar. It can track ballistic missiles in low Earth orbit, technically not an orbit, but a ballistic trajectory going in its area. It doesn't have any weapon systems to do anything about it, but it can see it happening. It will be part of the sensor network tracking ballistic missiles that will then be engaged with presumably a different platform. But the cool thing about the Sea Draft is that it's a combined surface search and air search radar all in one, and it can track hundreds of targets at the same time, including ballistic missiles. The Seastar Sapphire 3 EOS is the electrical optical system just forward of that radar. You can see it there. It's circled on the picture if you're watching the video of this. And right in front of that is the Bridgemaster E navigation radar, just used for normal everyday navigation. Kind of a poor placement for a navigation radar in that about 45% of its field of view is blocked by superstructure, but other than right behind the ship, it can see everything in high detail and is used for navigation when close to shore. Here is a great breakdown, a great drawing of the inside of the LCS. And I apologize to those of you only listening to this, but I will try to describe it. It is a cutaway drawing of all the different mission modules and locations of the rib boats and unmanned vehicles that are accompanying this ship, because it can use not only helicopters like the MH-60R, but the unmanned version of our helicopter systems, as well as unmanned surface vessels. We have both manned rib boats that you see here in the drawing, and later on we'll show you a photo of an unmanned surface warfare vessel that the Navy's been using for years, and we got a picture of one. So that's great to include in this little lecture here. It's coming up. Okay, forward is the ISR suite that's used for intelligence, surveillance, and reconnaissance. So you can stick one of these off the coast of another country and just listen to what's going on. They do support that kind of capability, as well as mine warfare and surface warfare capabilities. The ability to track ballistic missiles is a huge advantage in that this is a relatively fast, low cost when compared to, say, an Arleigh Burke destroyer ship that you can put off the coast of, say, Japan and watch North Korea, just as an example. This would be a great place to use this kind of ship, freeing up an Arleigh Burke that's currently doing that mission, steaming in a box that's 10 miles by 10 miles, very small for a ship, for months at a time, just to keep an eye on that country. A great use of the Independence class would be to position this some 50-man crewed vessel in that 10 by 10 box watching North Korea with its Sea Giraffe radar. All right, let's move on to how many they made. They made 17 of these. They decommissioned 2, and they aren't building anymore. This is the end of it right here. And this is all their commissioning dates. From the date the keel was laid down for the first time in 2006 to the final commissioning of USS Augusta all the way back in 2023. They're done building this class. Independence-class LCS by the numbers, they use a CODAG system, and that's a combined diesel and gas engine, or gas turbine, excuse me. They use 2 GE gas turbines to push 4 steerable water jets, propelling the ship in excess of 44 knots through the water. Now, if you want to go long distance, you can't go full speed. The max range of this ship is 4,300 nautical miles at 18 knots, which is still better than the Freedom class. You can get from point A to point B with a 40-man crew, but if you want to have a mission module installed, whether that's mine countermeasures or anti-surface warfare, or even ISR, keeping an eye on other countries, you're going to have a 75-man crew. And so that's why you'll see 2 crew numbers on both LCS class frames. You have the crew of the ship, and then you have the mission crew. So 24 AGM missiles are held in the bow. That's the AGM-114L Longbow Hellfire missile. They can carry 8 RGM-184 Alpha naval strike missiles, and they have the 57mm gun on the bow, like I said. The search radar is the TRS 3D and 4D search radar, the exact same radar that the Freedom class has. The Northrop Grumman ICS combat management system connects all of the sensors and weapons and internal communication, that's like bridge to the engine room, all together in the ICMS. Bridgemaster E navigation radar is the navigation radar right above the bridge. It looks like the letter T, and it spins around, and it's basically a short range but very high fidelity radar that will give you the position of very small ships, like a sailor, a fisherman in his little John boat will show up, as well as the coastline. And so you're literally mapping the coastline on your screen as you drive alongside of it, hopefully not into it. The ANKAX-2 electro-optical and infrared system is on board just forward of that navigation radar. That is simply a system that can track objects by shape, whether it's physical shape or heat signature shape, and it can be steered manually for searching, and it can also track automatically. Once you have a target, you lock onto the shape, and it'll track that shape. You have the ITES 3601 RESM, which is the electronic support measure, telling you what kind of radars are being transmitted out there. They have the WC6, which is the SATCOM, satellite communication system, allowing them to talk to other ships and to shore, make reports. That's very vital when you're in that ISR position. ISR is often done by lone vessels. Submarines, ships like this would be perfect because they're relatively low cost, least likely to be detected, and if destroyed, it's not a big loss to the Navy as a whole. And so having this communication system is like having an eye in the sky, or in this case, on the sea, right off the coast of another country, keeping an eye on things. The BAE nuclear active RF decoys are combo decoys that do chaff, flare, and other things to deceive incoming weapons, primarily cruise missiles, but other sensors as well. And then finally, the helicopter systems are the MH-60R, which is the most recent form of the U.S. Navy helicopter, as well as the MQ-8 Bravo Charlie Fire Scout. Fire Scout is the name of the unmanned helicopter the United States Navy has been employing for years now, and unmanned surface vehicles are used in there. So this is the LM2500 gas turbine engine, manufactured by General Electric, used in navies around the world, mostly NATO navies though. China copied this for their navy. It is a 2-shaft axial flow simple cycle turbine engine. It weighs only 4.7 tons and generates just over 25,000 kilowatts of energy. So you put a couple of these on your ship and you're going very fast very soon. It doesn't take a long time to get up to speed with these, which makes them very valuable to a ship. And more importantly, from a crew point of view, these things are extremely easy to maintain. And in the case that you need to replace them, it's a simple, relative to another ship, it's a simple job to pull into port with a crane, pop open the top, and then crane this thing out and crane a new one in say, a weekend. Compared to ships that don't have modular systems like this, which would require probably a dry docking period to do a similar function. Siege Raft anti-missile ballistic radar, manufactured by Saab. That's right, the same people that make the Saab cars that used to be here in the United States. Haven't seen one in a while. Also make a lot of military equipment. They're very proliferate in the military industry, and they make this radar. It's designated as the SPS-77 in the United States Navy, but it's used in other navies around the world, called the Sea Giraffe. It operates in a very narrow range. It's 4.5 to 5.9 gigahertz with a peak power of 25 kilowatts, which is pretty respectable, but it is a very narrow range of frequency operation, which would make it very easy to classify to another ESM system out there looking for it. Not necessarily a limitation of it at all. It's just you're making it's hard to hide once you start rotating and radiating with this thing. You can rotate at 30 to 60 RPM per minute. That's how fast the thing physically spins around on top of the ship. It has a range of just under 100 nautical miles. Can track hundreds of both air and surface contacts, and IOC'd in 2003. It's a very good system. Here's the ES-3601 RESM, made by L3 Harris. It's a tactical radar electronic support measure system. It scans anywhere from 2 gigahertz up to 18 gigahertz, can track up to 500 different tracks, which would be emitters. Remember, one platform can have multiple emitters, so it's important that you can do multiple of these. It's 360 degrees coverage anywhere their elements are facing, they're looking at. It comes with its own emitter library, meaning that once it sees an emitter, it compares it to the library, gives you a classification. So it makes the operator's job a lot easier because he doesn't have to memorize every single radar system in the world and its capabilities, even though a lot of ESM operators out there can do that and have that knowledge. Having this type of library on board is extremely beneficial, especially to young, inexperienced operators. This will help them classify radars quickly, which is vital to the job. All right, here's the active RF decoy manufactured by BAE Systems. This is a lingering decoy with an RF emitter. This thing will actually transmit itself as a target, trying to deceive and lure weapons away from the ship. It has solid rocket fuel propulsion to get it up and out of the tube and into the air. It has a short cycle time, which is a fast reaction time. Absolutely vital for decoy. Whenever a ship is surprised by an attack, which is probably how it's going to happen, they need to get this system functioning quickly. Of course, it's always going to be on when you're at sea, but you need to be able to mash the button and get the decoys employed quickly and effectively to save the ship. This can be placed in an automatic mode and a manual mode. A little note from personal experience, we always had the automatic mode disabled while at sea so that you did not have an inadvertent launch of a decoy because the system got confused and thought it was under attack. So that's just a personal story. I believe that's still how they operate. It makes sense to me whenever we did it that way back then. So probably manually operated, but it does have an automatic mode. All right, here's the Mark 110 57 millimeter naval gun, 57 millimeter caliber, 70 caliber barrel length, shoots 220 rounds per minute, is radar guided, capable of shooting programmable ammunition, has multiple types of ammunition from point detonating to a proximity fuse to other program modes. So it's a wide variety of different capabilities. This thing can shoot at incoming aircraft missiles with the proximity fuse. It can shoot at lightly armored vehicles like small pirate ships and stuff off Somalia with point detonating, which would be devastating to any kind of small craft. Or it can go into program modes where you're fighting against a naval craft that has a small amount of armor, so there's penetration before detonation of the round. It does all those things. The one downside that I see to every single weapon system on this ship, and this is a little bit of personal analysis, none of these guns look down. And in the world of sea drones, unmanned sea vehicles that we've seen in the Black Sea and Ukraine used against the Russian Navy, you need guns that look down and can engage automatically with radar guidance, not with crew members on board with small arms, because that's ineffective. So I'm very concerned. I imagine this gun must have some amount of negative depression, but it doesn't look like it's very much. Anyway, shoots has 1,000 rounds deployed below deck, so it can reload. Has a maximum range of 17 kilometers and weighs just under 7,000 kilograms. Here's the other gun system. This is mounted very high on the ship. So again, not going to be looking down, shooting down very much. So at the very top of the ship, up next to the navigation radars, are two Mark 46 30mm gun weapon systems. These are manufactured by General Dynamics. This is the Bushmaster Mark 44. Very reliable gun system, easy to maintain, great choice. Location, poor location, in my opinion, especially in modern warfare. You need to be able to shoot at the waterline to small incoming objects, like USVs. Shoots 200 rounds per minute, has a dual feed, 200 rounds plus 200 rounds coming onto each side, and it can be remotely operated from the CIC down below. Has a maximum effective range of 2 kilometers. Here's a CRAM point defense missile system manufactured by Raytheon. Raytheon makes, I think, inarguably, the best weapon systems, missile systems in the world. And so it's good to have them on board for our point defense. This is based on the Mark 15 phalanx mounting, but with the 20mm Gatling gun is replaced by an 11 cell, so 11 missiles of the RAM variety. That's rolling airframe. Fires the RIM 116 rolling airframe missiles, search and track radars, as well as forward-looking infrared and electrical optical system. And so if it's out there and moving, it can track it and see it in all different kinds of spectrums. Has an effective range of 15 kilometers if it's using the Block 2 missile, which presumably it will be. And this ILC'd in 2009. This defends the ship from attack. Now, AGM-114L Hellfire, manufactured by Lockheed Martin. Vertically launched missile system, surface-to-surface missile system. This one certainly could engage unmanned surface drones, vehicles coming at the ship, for sure. It's a short-range anti-ship missile, range of 8 kilometers, 45 kilograms weight, 9 kilograms high-explosive anti-tank warhead with a proximity fuse. This enabled, or IOC'd, I should say, in 1989, but that was for the Army, and this longbow version for the Navy IOC'd in 2018. And finally, we get to the RGM-184 Alpha Naval Strike Missile, manufactured by Kongsberg. Long-range anti-ship missile is in excess of 180 kilometers. It is subsonic. It's got a 125 kilogram high-explosive warhead. Uses GPS, internal navigation, and Terracom guidance with an infrared seeker to find its target. And there you can see, if you're looking at the video of this, there are 2 quad launchers. So one facing port, one facing starboard, total of 8 missiles. This IOC'd in 2012 is essentially the replacement for the Harpoon, and it is just the next generation long-range subsonic anti-ship missile. Here's the MH-60R helicopter. This is the Seahawk, the latest of the Seahawk variants. It uses two GE T700 turboshaft engines. Has a range of 450 kilometers, can stay in the air about 3.5 hours before having to come back home for fuel. Has door-mounted machine guns, multifunction radar, electrical optical tracking systems. That's that big round thing on the nose right in front of the pilots there. And also has sonar buoys. This has ASW capability. And here's the Mark MQ-8C unmanned helicopter, manufactured by Northrop Grumman. It's based on the Bell 407 frame. That's why it looks a little bit like a miniature Huey, in my opinion. It's the RR. It's powered by the Rolls-Royce 250 C47 Bravo turboshaft engine. Creates 813 shaft horsepower. Can stay in the air for 15 hours, much longer than the manned helicopter can, but carries a lot of the same sensors, including electrical optical sensor systems and a starlight radar option. I also am told that this has sonar buoy launchers installed. However, you don't see them here in this picture. So this probably can support anti-submarine warfare as well. And finally, here's the RIBs, the unmanned naval platforms. We have the RIB boats are manned, just to be clear. The unmanned naval platforms are the one you see on the left. This is one of the first pictures I've been able to get from the DoD for our lectures here. This is a completely unmanned vessel. It can go out and perform the same duties other than boarding operations, which requires an actual person to go board another ship. This can go and communicate with other ships. It has its own navigation system. It's completely autonomous. You give it a mission, it goes and does it. It's quite incredible. The United States Unmanned Naval Program, Unmanned Systems Program, whether it's aviation, surface or subsurface, is extremely advanced compared to other countries. We don't talk about it because it's very sensitive and very secret. It's one of our major advantages in this generation of warfare we find ourselves in. And we certainly aren't going to brag about it. But this is a great photo. And full credit to Tafon Osbrecht, our technical writer, for getting this photo. This is his work. And well done, sir. So that's a brief glimpse into what one of our unmanned naval vessels look like. These things are hoisted in and out of the Independence class. I imagine that's not a very rapid procedure at all, but that's how they do it. All right, final thoughts on the Independence class is that, man, this is very different than the Freedom class. They went with two wildly different designs here, and arguably the Independence class is better than the Freedom class because they haven't decommissioned as many Independence class as they did the Freedom class. Now, comparing your success to the Freedom class is not the best comparison because the Freedom class is a disaster whenever it comes to many things, including staying commissioned. It's not very good at that. So the problem with the Independence class is this is the ship that had the hull cracking where the bow met the trimaran hull, right where that pointy nose meets the hull. That sees a lot of wear and tear, a lot of stress when at high speeds. So there was an order given out to the Navy saying that thou shalt not go above 15 knots because you're cracking the hull of these aluminum trimarans. And so they were limited in speed for the longest time. Yeah, they could go more than 44 knots, but they would rip themselves apart doing it over time. And that's still being addressed because that's a design issue. They had to reinforce where those hull pieces meet, which has been done, by the way. So that's the design issue with the Independence class. Obviously, the Freedom class had the gear transmission ratios were incorrect, so the transmission ripped itself apart when you combine the gas turbine with the diesel. With this design, they don't have that issue. They can use both and go very fast. But now the hull is the weak point, not the engine. And the hull literally is ripping the bow off. And of course, that would be catastrophic for the ship if it completely failed. And so they are decommissioning this as well. Two have already decommissioned. The others remain in service. And it is a really good platform at low speeds. It's very good at ISR. It can track a ballistic missile submarine at a very low cost in terms of manpower. So that's great. Ballistic missile launch, rather. It can track a ballistic missile coming out of China, North Korea, wherever, freeing up other assets to do more important jobs or more flexible jobs like the Arleigh Burke class can do. And that's really where the Independence class lies. It is a flawed system that is functional, and the Navy will use these for as long as it can, but the decommissionings have already begun. All right, and that's Independence class. This concludes the LCS series of 2. We are moving on to the aircraft carriers, the ballistic missile submarines, and finally the Arleigh Burkes. We will be doing those next.